In 1785, French physicist Charles Coulomb solved the problem of varying the quantity of charge in a controlled way. This is the type of apparatus used by Coulomb. An insulating rod with small conducting spheres, A and A' at each end was suspended by a thin wire. A similar sphere, B, was placed in contact with sphere A. When they were touched with a charged object, the charge spreads evenly over the two spheres. Because they were the same size, they received equal amounts of charge. The symbol for charge is Q. Therefore, the amount of charge on the spheres can be represented by the notation QA and QB. Coulomb found how the force between the two charged spheres depended on the distance. First, he carefully measured the amount of force needed to twist the suspending wire through a given angle. He then placed equal charges on spheres A and B and varied the distance, r, between them. The force moved A, which twisted the suspending wire. By measuring the deflection of A, Coulomb could calculate the force of repulsion. He showed that the force, F, varied inversely with the square of the distance between the centers of the spheres. To investigate the way in which the force depended on the amount of charge, Coulomb had to change the charges on the spheres in a measured way. He first charged spheres A and B equally, as before. Then he selected an uncharged sphere, C, of the same size as sphere B. When C was placed in contact with B, the spheres shared the charge that had been on B alone. Because the two were the same size, B then had only half of its original charge. Therefore, the charge on B was only 1/2 the charge on A. After Coulomb adjusted the position of B so that the distance r between A and B was the same as before, he found that the force between A and B was half of its former value. That is, he found that the force varied directly with the charge of the bodies. After many similar measurements, Coulomb summarized the results in a law now known as Coulomb's law. The magnitude of the force between charge QA and charge QB, separated by a distance r, is proportional to the magnitude of the charges and inversely proportional to the square of the distance between them.